My name is Artie. My talk today is titled Jest in Strict Mode, and it's about a short story about me trying to find and prevent flaky tests in a test suite of over 1,000 tests, 10,000 tests, sorry, not 1,000 tests. So a little bit about me. I actually work here. I work at Wayfair for a team called Front-End Auxiliary Engineering. Our goal is to basically help engineers. We want to improve the developer experience at Wayfair for all our front-end engineers, and we want to help teams build new React apps from scratch. The way we do that is we embed on teams for about a quarter out of the year, and we establish good practices and help engineers level up their expertise along the way and help them continue what we teach them after we leave. The way we accomplish that is through education and pair programming. So during our pair programming sessions, we write a lot of tests and we TDD a ton. So we kind of see what issues people run into along the way. We've been doing this for about a year now. We have a very small team, but we finished about 6 projects now. What we learned along the way is that it's kind of difficult to get tests right, especially in React. A common question is like, what's even a good React test? It's not simple to answer. You kind of need a lot of like trial and error to figure that out. Have some experience, or somebody just can answer that question for you. So we try to bridge that gap because we can't pair program with, I don't know, 2,000 engineers that we have at the company, right? So we build a lot of tooling and support to help people get to the right answer. Again, just to help them kind of like answer their own questions about tests, right? So we have ESLint, we have static code analysis, even code coverage, right? To kind of indicate whether or not a test that they wrote is a good one. But it still falls short, and we do have a number of flaky tests that we have to fix from time to time. Flaky tests are not great. Like this guy, Martin Fowler, I don't know, you might have heard of him. He says that non-deterministic tests have 2 problems. Firstly, they're useless. Secondly, they're virulent infection that can completely ruin your entire test suite. Right? I agree. But I think there's another point here that I want to add is that flaky tests are kind of useful in a way, or maybe not useful, but they give you a little bit of a piece of information that tells you, hey, this test is wrong. There's something wrong with this test. Go and fix it. I think a more dangerous test is a test that never breaks, because these tests will have no obvious issues. They look fine on the surface, but they're potentially hiding some harmful code that might get into your production, and you won't know about it until you get an angry email at 2 a.m. They can also break other tests, and I will demonstrate that later. And they're insanely difficult to track down because imagine an engineer pushes some code to a PR, everything's green, they don't know that it's bad, right? How will we figure that out? So it's kind of like we set out to fix that by identifying these bad tests when people actually commit code. So here's an example of what I'm talking about. A very basic example of a React test. We're using an enzyme here with Jest. So we mount a component, we render some cards, we expect each card to have some property. It really doesn't matter. The engineer that wrote this, they TDD this from the beginning. They wrote the test first, then they implemented the cards. The test was failing, then it was passing. But what happens when engineer 2 comes in and decides to render a fancy card or delete all the cards altogether? What happens if cards are not found and it's an empty collection? Well, iterating over empty collection does nothing. And this expectation never runs. So this test still passes, but it's completely broken. So how do we fix this, right? So Jest actually has, another thing, the logic in Jest, whether or not a test fails, is basically like whether it threw, right? So if it doesn't throw, it passes. That's pretty basic, straightforward, easy to remember. So the way we can fix this is we can assert that array actually has some sort of length that's reasonable, or we can add this very generic assertion that says, hey, this test just needs to run some number of assertions. Doesn't matter how many, just one at least, right? So this is great. I really like this. It's really useful. It's something that we document in our docs for all of our engineers, something we want them to do. However, when I started looking into this, I was like, oh, this is awesome. Like, let's ask all the engineers to change their 10,000 tests. That wasn't going to go over well. So I was like, okay, well, I know of this other test runner called Ava. I use it in my open source projects, and it has this config option that says, hey, for all the tests in this test suite, fail them if they don't run any assertions. I was like, oh, great, like Jest should have that too. So a little bit of quick Googling, I found out that the Jest team is not about that life. They're not gonna implement that in Jest. And they actually have pretty good reasoning. They're saying that like they don't want to couple the Jest test runner with an assertion library, which totally makes sense. So I was like, okay, that doesn't seem that difficult, right? Like if they don't want to do that, maybe I can write a plugin to Jest that can actually do that. I can just do it myself because tests are a function, and I can just wrap some functions and extend the Jest API and just add this expect has assertion thing to it. So that's what I set out to do. I wrote this very simple plugin. It just adds this one line. Except that when I was getting ready to publish it, I said, well, I should make sure that the thing that I'm writing to improve test experience for people is also tested. So I started writing some test cases. So here's one that I came up with, a very common mistake in the async test if you're using promises. So if you look at this, there's a promise that's instantly resolved, and then it adds an expectation with that then, but that gets hidden. That like never gets observed by Jest because the initial promise is returned. So it's a common issue with React code. So this is just a deconstructed version of this. So this test passes. Has assertions doesn't help here at all because Jest says that the assertion was counted as part of the suite or this test, but the expectation failure, which is obviously wrong, doesn't count. So it's like a disconnect between where's the assertion gets counted versus where does the failure gets counted, I guess. Yeah, so this runs eventually, but it never fails the test. So I realized that this is not a very easy problem to find. And originally I pointed this at our 10,000 or so tests, and I got like 1% of tests to break, which is great. That's about 100 tests. That's a good find, depending on how you look at it, I guess. But I realized that like, well, we can't just ignore these async tests, right? Because most of the code in React that's actually worth testing is gonna be doing something async sometimes, at least, because maybe you want to test an integration test where you have a service module that needs to update some state in your component. Like that's an important thing to test. We can't just ignore that. That needs to work correctly. Our tests need to be reliable. So I set out to see how else can I break my plugin, and I wrote this bad boy. So I don't know if you know, I don't know if you can tell what's going to happen here. So here I have two tests back to back. One sets a timeout, then ends the test with a done, then sets another timeout, and writes a really bad expectation that should always be false. And then the second test just kind of doesn't do much. So what happens here? That's right, it's just issue 8297 happens here. Because the second test fails with the expectation that got spawned from the first test. And this is what happens when you write code in JavaScript. It gets really complicated really fast, and it's really hard to keep track of all this async logic. And it might sound like I'm trying to bash Jest. I'm not. It's just like, this is just really crazy stuff that you can do in JS. Tim from Jest team was kind enough to answer this issue. He said that, yeah, they do some awaits, and these awaits kind of mess with the assertion counts. That was the first example that I showed for the promise example, the very basic one. And then he also mentioned the Zone.js library that could maybe help out in doing something to fix this issue in the future. And he kind of mentioned some strict async or debug mode for Jest that got me thinking. So I said, okay, what can we do about this? I started stressing a lot because I was like, oh God, we're never going to find all the problems in our test suite. It's always going to be an issue. And then I decided to look into the Zone.js library, and I really like what I found. So Zone.js is, I basically just call it magic. I think there's a whole conference, an hour conference talk worth of material to talk about Zone.js alone. It's basically an async context in JavaScript, and what that means is it allows you to track async events happening, like spawning from a single function root. So you have, that could be Jest test, for example. And when you wrap your functions in the zone, this is this concept of a zone, then you can intercept all the async events that happen from that zone. So that could be a set timeout, or a promise, or any other asynchronous callback. And it's really useful because it actually gives us control over when async events are allowed to happen from a test. So I incorporated into my plugin this concept of zones, and it was really useful because I was already wrapping the test functions, so all I had to do was wrap them in this additional zone. And the logic became pretty simple. It's kind of like, if the test is still active, if the test that spawned this async event is still active, could let the task continue, let it run. So like our promise example. Or if it's the test is done, then just ignore the task. Just don't do anything with it. Just ignore it and log a warning to the console. Let the engineer know that, hey, you spawned the task from your test, but your test is already done. So don't do that. It's pretty useful. The way you use it is you just npm install or yarn add jest plugin must assert, and you add it to setup files after end, which is a jest 24 plus config option, and it just kind of like decorates all the tests that run in your suite with this additional functionality. So I'm going to try to do a live demo. Hopefully, of course, it's not full screen. All right, so this is the example from before, demo.js, and I'm running this in my plugin test repo. So I'm just going to run this. So this is what happens when you run it with the plugin. So it runs the demo, and both tests fail. And then it gives you a little stack trace that says, hey, assertion after done callback 1 is attempting to invoke a microtask, set timeout. After test completion, see stack trace, and these stack traces actually show you which line in your test spawned this timeout, and you can see it bounce between two different timeouts and it kind of leads you back to the problem area. So this is what we have running now in our code base. I think we have way over 10,000 tests now, and this has been helpful in finding these flaky tests and actually preventing them from getting into the code base, which is a much better path forward versus like trying to hunt them down after the fact. Some alternatives is, I don't know, I added the slide because I thought maybe one day Jest, I like Jest, maybe one day they decide to not use a global expect library. I think that would be a lot better. That's kind of like what Ava.js does. They don't run into these issues as much. So yeah, at the end we have correct test results. This actually found 3% of our tests to be flaky or have false positives, which is a much bigger number when you think about tens of thousands of tests. It gives developers immediate feedback because as they write their tests, this just incorporates behind the scenes and it tells them like you didn't run assertions or you try to spawn some tasks that you weren't supposed to. And yeah, it prevents new and flaky tests from entering the system. That's it.